Before we start anything, let's think about how we can solve this question. Here we have trigonometry terms in the numerator and the denominator. If we express the numerator terms as the sum of the denominator, the differentiation of the denominator, and a constant using the constant value a, b and c, then we can divide this numerator value from the denominator value separately. After that, we have three parts. The first one is a constant value. The second one is a constant times the differentiation of the denominator over denominator. And the last one is a constant over denominator. After that, the first part becomes a constant time the integral of 1. The integral of 1 equals x. The second part becomes a constant time ln modulus denominator. And the last integral we can simplify using u equals tan x over 2 substitution. Clear? Let's jump into the question. Let's write the numerator value as capital A times denominator plus capital B times differentiation of the denominator plus capital C. Here capital A, B and C are constant to be determined. So we can write 25 cos x plus 15 value as capital A times 3 cos x plus 4 sin x plus 5 plus capital B times minus 3 sin x plus 4 cos x plus capital C. Then we can remove the brackets and get cos x as a common factor from cos x terms. Then we have 3a plus 4b times cos x. After that, we can get sin x as a common factor from sin x terms. Then we have 4a minus 3b times sin x. Finally, constant values 5a plus c. After that, we can compare the coefficients. First one, coefficient of cos x. Coefficient of cos x in the left hand side 25. In the right hand side 3a plus 4b. So we can write 25 equals 3a plus 4b. So we can write 3a plus 4b as 25. Coefficient of sin x in the left hand side 0. Because there is no sin x term in the left hand side. In the right hand side we have 4a minus 3b. Then we have 4a minus 3b equals 0 equation. Final one, constant. In the left hand side, constant value 15. In the right hand side, 5a plus c. Then we can write 15 equal 5a plus c. So we have an equation 5a plus c equals 15. Let's move to equation number 2. From equation number 2, we have 4a equals 3b. Then we can write 3b as 4a. We can subject b as 4a over 3. Let's move to equation number 1. We can substitute instead of b value 4a over 3. After that, we have 3a over 1 plus 16a over 3. Now we can get a common denominator as 3. Then in the numerator, 9a plus 16a over 3. 9a plus 16a equals 25a. We can cancel out 25 value and cross multiply denominator value 3. Then a equals 3. Let's substitute this a equals 3 value for capital B. Then we have capital B value as 4. Let's move to equation number 3. We know capital A equals 3. So 15 plus C equals 15. Then C equals 0. Then we can write numerator value 25 cos x plus 15 value as 3 times within bracket 3 cos x plus 4 sin x plus 5 plus 4 times within bracket minus 3 sin x plus 4 cos x plus 0. Now we can divide numerator values from the denominator value separately. Then we can cancel out numerator value and the denominator value. 0 over 3 cos x plus 4 sin x plus 5 value equals 0. So we don't need to simplify this integral using u equals tan x over 2 substitution. Then we can consider integral signs separately. First one, integral 3. Second one, integral 4 within bracket minus 3 sin x plus 4 cos x over 3 cos x plus 4 sin x plus 5. 3 and 4 are constant value. So we can bring these constant values outside of the integral. Integral 1 value equals x. In the second integral, we have differentiation of the denominator value in the numerator. So we can write this integral value as ln modulus 3 cos x plus 4 sin x plus 5.